Jennifer Dionne earned bachelor's degrees in systems science and engineering and physics from Washington University in St. Louis in 2003. She went on to earn a doctoral degree in applied physics from the California Institute of Technology and currently leads the Dionne Research Group at Stanford University as an assistant professor. To honor her early contributions to science and technology and engineering education, Dr. Dionne is the recipient of the school's 2012 Young Alumni Award.
Her research is so important to the industrial world that she has close collaborations with industries such as Bosch. And so she not only has grants with the Department of Energy, but she's linking also with corporations. And she was recently awarded in her young career a very prestigious award by Technology Reviews. It's put out by the Massachusetts Institute of Technology. And over the 11 years of these awards, one could follow the new technology trends by how these young investigators are pursuing their own research. Jen was awarded this, as well as a career award by the National Science Foundation, as well as an Air Force Research Career Award as well. So her research is just not an academic enterprise. She works very closely with students, she works very closely with industry, and her research is applicable to many different fields.
Dr. Dionne holds 2 patents, and her work has been featured in Science and Nature. Today, the Dionne Group works to improve the design and efficiency of a technology called upconverters.
A lot of our work is kind of generally in the area of optics and photonics, and one of the specific applications that we target is solar energy. So how can we take sunlight and efficiently convert sunlight either into electricity or into a fuel that could be stored and then transported. So our group has been working on kind of new upconverting materials, new upconverting methodologies that can take lower energy photons from the sun that would go to waste in most solar technologies and combine them together into a photon that can then be used by a solar cell, basically to allow photovoltaic devices to use much more of the sun spectrum.
It's really appropriate that Jen get this award, because now the Department of Mechanical Engineering has changed its name in the last couple of years to reflect the emphasis on material science. So it's now Mechanical Engineering and Material Science. In addition to that, we're now developing interdisciplinary groups with chemistry, with physics, as well as with engineers, to approach material science from a broad in a very deep way. So Jennifer's research and Jennifer's sort of background, starting here in Washington University in systems engineering, now moving into mechanical engineering and material science, she's very appropriate to sort of show the kind of visibility in this area.
I think kind of throughout my years at WashU, I became a bit more interested in kind of light, optics, kind of interesting things that you can do controlling light for various applications. It's hard for a lot of people to associate with what nanomaterials are, what makes them unique, and what are their applications. So part of my outreach is kind of driven at just allowing people to understand what are the impacts of nanoscience in their daily life, and what are the interesting applications that can emerge. So kind of to help along this line, I've paired up with a local San Francisco artist and also a TED Fellow who makes nanoparticles of silver. So silver is normally shiny, pretty reflective, like most mirrors are made of silver, or your silverware. But when you, take silver and shrink it down to the nanoscale, it starts to scatter colors that are very vivid, like blues, greens, oranges, based on the size of the nanoparticle. So this artist made nanoparticles and now makes macro scale art pieces, like she's a painter. So that was, kind of part of the nano art exhibit, where we got to introduce kind of the general public to the more visual side of nanoscience.
I think you'll see when you meet her or talk to her a sense of excitement and her charisma, and the fact that as a young woman she could really contribute to the engineering field. So I think students are going to see a model of how someone at her young age could do all of this and contribute so much to society at the same time, which is why we gave her this award.